Okay, pre-cal students, in this video we will be looking at the characteristics of exponential functions and also how to graph them, okay? Your heading for today is exponential functions, and the lesson number is 7.1. 7.1. Be sure and include today's date with your notes if you would, please. So again, your heading today is exponential functions. The lesson number is 7.1, and be sure and include today's date, okay? Be sure and include today's date. Alright, let's continue on. Now, in this chapter, we'll be looking at two different types of functions, okay? Exponential and logarithmic, okay? Exponential and logarithmic functions. Now, these two types of functions are also called transcendental functions, okay? Now, let me stop and say this. You do not need to write this in your notes right here, okay? And you also do not need to write this in your notes either. Okay, you do not need to know that these two functions are called transcendental functions. I'm just letting you know that. And I'm also going to let you know this here, but you do not need to write this in your notes either. Transcendental functions are functions that do not satisfy a polynomial equation or a polynomial function. For example, remember, a polynomial function is a linear function or a quadratic function or a cubic function or a quartic function, okay, and so on and so forth. There's more than that. And so what I'm trying to show you is that a exponential and logarithmic function do not fit any of those categories. Thus, they are not a polynomial function. Thus, we call them transcendental functions, okay? So these are the two types of functions that we are going to be studying in Chapter 7, and they are transcendental functions, okay? And you do not need to know all of that. I just wanted to give that information to you, okay? Okay, continuing on. Okay, now students, here's an example of an exponential function, okay? An exponential function. Now copy this in your notes, okay? Here it is. Please copy this down. Y equals 2 times 1/3, and 1/3 is risen to the x plus 5 power and then minus 3, okay? So copy this in your notes, please. This is an example of an exponential function. Alright. Now let me show you some things about this function you need to know. Okay? Copy this down, please. Number 1. This is the base right here, 1/3. The 2 is not the base. The 2 is being multiplied times the base. Okay, it's a scalar or a multiplier, but the base is 1/3. Okay? So the base in an exponential function must always be greater than 1. Okay, so please make note of that. Also make note that the base cannot equal 1, okay? The base cannot equal 1. So this base right here, that is the base of the exponent, must be greater than 1, and it cannot equal 1, okay? I'm going to pause while you quickly copy that down. It's very important that you know that. These are characteristics of an exponential function. Now, students, something else to know is this. Notice the unknown is in the exponent. Your exponent is x plus 5, okay? Right here. Okay, and notice that your unknown x is in the exponent. All of these characteristics must be present for you to have an exponential function, okay? So the base must be greater than 1, it cannot equal 1, and there must be an unknown in the exponent, okay? So make note of all of this, please, before we continue on. Okay, now, before we get into graphing these, let's first take a look at the usual shape of the graph and some characteristics of the graph of an exponential function, okay? So go ahead and draw in your notes a coordinate plane, okay? Go ahead and quickly draw a coordinate plane. And then here's the usual shape of an exponential function, okay? They might look like this. They might be turned this way. Or they might be turned this way. Or they might be turned this way. But they're always going to be curved like this, okay? Also, please make note, students, that an exponential function always has this. It always has a horizontal asymptote, okay? Always. Now, in case you've forgotten what a horizontal asymptote is, it's an imaginary dotted line that the graph will never cross. For example, let's pretend this graph right here is getting closer and closer to positive 1, like this, okay? Just forget the other graphs for a second here. We're going to look at this graph right here, okay? Now, notice that this curve might be getting closer and closer to 1, like this, but it's never going to cross it. And that means you have a horizontal asymptote at y equals 1, because the horizontal asymptote is crossing the y-axis at 1, okay? So listen, make note of this in your notes. Every exponential function will have a horizontal asymptote, okay? Every single one. So it's important that you know that. And they're all going to be curved like this, okay? I'm just pausing to take some really good notes of this, okay, guys? You need to know the general picture of what the graphs look like, okay? Now, let me give you 4 quick basic steps that will help you graph exponential functions quickly and accurately, okay? So here we go. Please copy these down. Okay, first of all, always find the horizontal asymptote. Always find that first, okay? Every exponential function will have a horizontal asymptote. Now here's how you find it. The horizontal asymptote is always whatever the constant term is. Now I'm going to show you later what that means, okay? But the horizontal asymptote is always the constant term, okay? I'll give you a quick example right now, real quick. If I had this right here for an exponential function, the constant term is -3, right there. So what that means is I know right away that my horizontal asymptote is at y equals -3. Now we'll get into that later, okay? But write this down for step 1. Always find the horizontal asymptote first, okay? That's the first thing you always want to do. Now step 2, set the exponent equal to 0 and solve. This number will be the middle value on your table of values, okay? So set the exponent equal to 0 and solve. Okay, step 2, set the exponent equal to 0 and solve. This number will be the middle value on your table of values. Okay, number 3. T of V means table of values, okay? So make a table of values with 5 ordered pairs. Remember to use your value from step 2 for the middle of your table of values, okay? So remember to use your value from step 2 for the middle of your table of values. Step 2, set the exponent equal to 0 and solve. Okay? Okay, step 4 is sketch the graph. Sketch the graph, okay? So not too difficult, guys. Actually, these are really simple to graph if you'll follow these 4 steps. Okay, so here we go. Let's go ahead and let's try to graph 2 of these. And then we're going to continue on to look at a topic called the natural base E, okay? So here we go. Now go ahead and copy this in your notes, students, if you would. We're going to graph this function. And then go ahead and get your calculators. And then also go ahead and draw a coordinate plane here, okay? Alright, let me go ahead and slide this down here so we can do some work with it. Okay, here we go. Now students, the first thing you want to do probably is find the horizontal asymptote. Now notice this 2 right here is not your constant term. It's your base, okay? It is your base. So this exponential function here does not have a constant term. So you put plus what? 0. Plus 0. So that tells you right there your horizontal asymptote is going to be a 0. Okay? So now you know something about this graph. Now you know the graph will either take place above this line or below this line. Okay? So there's a horizontal asymptote at 0. Now let's continue on. So step 1 is done. We found the horizontal asymptote and we put it on the graph. Okay, now step 2 says to take your exponent and set it equal to 0 and solve. Okay, students, so next we take our exponent, x minus 2, right here, and we set it equal to 0 and we solve like this. So bring the 2 over and make it a positive 2. And x equals 2. Now students, what that does for us is it gives us our middle value on our table of values. Okay, so step 3 says to write a table of values that holds 5 ordered pairs, okay? Now this 2 right here from step 2 goes right in the middle. So students, everything I've done so far has been really simple. First of all, you look for your constant term. In this case, it was 0. So you know you have a horizontal asymptote at 0, okay? That's easy enough. Next, you take the exponent, set it equal to 0 and solve. That's easy. That's your middle value over here, okay? And then for your other x values, just go up to 3 and 4, and then go down 1, 0. Okay, now, the next thing I want to teach you guys how to do is how to enter this into your calculator, okay? So we're going to enter this into our graphers. Now, first of all, let's make sure that our window is correct, okay? So here's what I want you to do. Go ahead on your calculator and push the zoom button, which is right here. Okay, now when you push that, you're going to have 7 options appear. Option number 6 should say something like this: Z standard. Okay, scroll down and hit enter on that. Now when you do that, it sets up your coordinate plane so that you have 10 positive this way, 10 negative this way, 10 up on the y-axis, and 10 down on the y-axis. Okay, that's the first thing. The first thing you want to do is set your window. Now the next thing you want to do is enter the equation into your calculator. Okay, so this equation here is going to go into your calculator. So next, hit y equals right here. Okay, go ahead and hit that. Now, next you want to type in to your calculator the function right here. So there should be some y's over here. There should be y1, y2, y3, etc. If there's any equations in there, go ahead and delete them, okay? Make sure that you have a perfectly empty window. Now, right here, y1, there should be an equal sign. So, here's what you type. See this 2 right here? Hit 2. Then hit the arrow button, which is right here. There's the arrow button right there, okay? Hit the arrow button, and this will pop up. Now, students, always put parentheses around your exponent, okay? Always. So put a parentheses, and then type in x minus 2. There you go, you're good. Now, Mr. Arrow, why do we do that? Because, students, once you enter this equation, your calculator will give you a perfect table of values right here, okay? So hopefully everything's going well so far. Now, next, come over here on your calculator. Now that you've entered this, go ahead and look to this button right here, okay? Right here. And right above it, you should see a word that says table, okay? Tables. You're going to push. You're going to push your second button right here, and then your graph button right here, okay? And when you do that, up will pop a table of values. Okay, now, if you're getting some really weird numbers out, do this, okay? Push second, and then right here above the window button, it should say in yellow, table set. So push second, and then push this button. Now, when you do that, here's what you should see. You should see table setup right here. And then it should say table start. And you probably want to start your table at 0. So I would make that as 0, okay? So just make that as 0. And then next, you're going to see a little triangle, and then TBL. You want to make this a 1. What that means is you want your table of values to go in increments of 1. So make that a 1, okay? Then hit quit, so hit second, and then mode to come out of this. So second, and then mode for quit, and you should be okay. So now, go back to your table. So hit second, and then graph, and your table should be all set, okay? Now, scroll down, and you'll see that 4 gives you out a 4. And 3 gives you out a 2, and 2 gives you out a 1, and 1 gives you out a 0.5, and 0 gives you out a 0.25 like this. Okay, so now I can very quickly plot these points and draw my graph. So over 4, up 4, over 3, up 2, over 2, up 1, over 1, up a half, and then over 0, and 1/4. And look, guys, look at the y values getting closer and closer to 0, but they're never going to touch 0. 4, then 2, then 1, then a half, then a 1/4, okay? So the graph's going to go like this. It's going to get closer and closer to the horizontal asymptote, but it will never touch it, okay? It's going to continue to go up like this. And you might say, Mr. Earhart, is there a vertical asymptote? And the answer is no, there's not. Even though this graph is very gradually getting wider to the right, it is still continuing to go more and more to the right, okay? So there is no vertical asymptote, but there is a horizontal asymptote, okay? So there we go. That is how you graph an exponential function. Okay? Now let's go ahead and try another one real quick here. Okay, go ahead and copy this in your notes. And you're welcome to work ahead or stay with me, however you want to do this, okay? So here we go. Okay, step one says to find the horizontal asymptote, which would be your constant term, okay? So 2 is your base. Okay, and by the way, your base is not -2, okay? If it was negative 2, the -2 would be in parentheses, okay? So your base is 2. So your constant term is +5 right here. Now, if it helps you to rewrite this like this, then feel free to do that. Some students like to put the negative term first like this, and then the +5. Either way, it's fine, okay? But the main thing I want you to see is your horizontal asymptote is at y equals 5. Okay, let's go ahead and put that up here. 1, 2, 3, 4, 5. So here's your horizontal asymptote right here. Okay? So now we know the graph is either going to be above this line or below this line. Okay? Now step 2 says to take your exponent, set it equal to 0 and solve. So your exponent is -x. Now students, if you can't see that on the screen, there is a negative sign right here with the x, okay? It's 2 to the -x power, okay? So -x equals 0. Now divide both sides by -1. X equals 0. So remember, that's your middle value on your table of values. Okay, so here's your table of values. And 0 goes right in the middle. And now I would go up 1, 2, and then go down 2, -1, and -2. Okay? Now here we go again. Your window should already be set, but in case you want to do it again, you would hit zoom and then option number 6. Okay? Also, your table set should already be set. Okay, but if you want to check it, you would hit second and then window for your table set. Okay? Alright, now let's go ahead and enter this function into your window. Okay? So hit y equals right here, and all of these will come up. Your y1, your y2. Now students, I would delete the functions in there if I were you. But if you want to leave it there, that's fine. It's totally up to you, okay? So, go ahead and enter this function. So you would hit 5, and then -2, and then hit arrow, which is right here. And then remember, always put your exponent in parentheses. Always, okay? So parentheses, -x, and then close your parentheses, okay? And then hit second graph. And your table of values should pop up, okay? Let me get my calculator caught up here real quick. And let me say this, students, to you. If you left the original function in here like this, that's fine. And you say, well, Mr. Earhart, I don't want that function. I want it there, but I don't want it showing up on my table of values. Then make sure the equal sign right here is not highlighted. Okay? okay, just move your cursor over to the equal sign and hit enter on it, and it will quit flashing, okay? So if it's highlighted, then that means it's going to show up. If the equal sign is not highlighted, then it's not going to show up on your table of values or your graph, okay? So here we go. Hopefully you have this typed in. So hit second and then graph for your table of values. And let's see what pops up here. Okay, here it is. For 2, you would get 4.75. For 1, you would get 4.5. For 0, you would get 4. And for -1, you would get 3. And for -2, 1, okay? So the graph would look like this. Over 2, up 4.75. To here, 1, 4.5, 0 is 4, -1 is 3, and -2 is 1. So the graph will look like this. Notice it's getting closer and closer to the horizontal asymptote, but it will never cross it, okay? And there we go, okay? So really, students, not that difficult as long as you use the 4 steps I've given you. They're really not that difficult to graph, okay? All right, let's continue on. Okay, now we want to look at something called the natural base E, okay? The natural base E. E is a number, okay? And here's what E equals. Now, you do not need to memorize this, okay? But it's still important to write down so you know what E stands for. Now, students, the number E comes from this limit right here. And we're going to study limits later on this year, okay? But the letter E, or the number E, comes from this limit right here, okay? And we're going to learn later what this means and how limits work, okay? But I just want to show you where it came from. Now, E is usually just used as a base. For example, here's how we would use the natural base E right here. G of x equals -E to the -2x power plus 1. And of course, your base here is E. And that's usually how E is used. And that's why it's called the natural base E, okay? Now, let's go ahead and graph one of these, an exponential function that has E for its base, okay? I want to show you guys how to type this into your calculator and how to graph these, okay? So here we go. Go ahead and copy this in your notes, students, right here. G of x equals -E to the -2x plus 1. Okay, here we go. Step 1, let's find the horizontal asymptote, okay? Well, your constant term is 1 right here. So your horizontal asymptote would be at +1. So there's your horizontal asymptote. Okay, step 2, take the exponent and set it equal to 0 and solve. So -2x equals 0. Divide both sides by -2. and x equals 0. So that would go in the middle of your table of values. Right here, okay? So we go up to 1, up to 2, down to -1, down to -2, okay? Now, here's how you type this in your calculator, okay? Watch carefully. First of all, you want to hit y equals right here, okay? Now again, if you want to leave in your other two functions, that's fine, okay? Just make sure the equal signs are not highlighted for those other functions. Okay, that's up to you. So let's say you enter it down here at 3, okay? Here's what you would type. You would type a negative sign right here. For this e, a negative sign. So negative sign. And then next, you want base e. So look right over here to your third button up from the bottom. 1, 2, 3. Okay, right here. So we're going to put, we're going to hit second right here, and then this button right here. Now when you do that, here's what's going to pop up on your screen, okay? You already have your negative sign. Then an E is going to pop up. And the arrow should pop up too, with the parentheses. All of that should have popped up, okay? So next, you would type in the exponent, -2x. And then close your parentheses, okay? And then put +1. So there we go, okay? Now you're all set. Okay, so having done that, then go ahead and hit, so you can fill in your table of values. Go ahead and hit second, and then graph for your table, okay? And if you do that correctly, you should get this up for your table. -2 would be -53.6. So that shows you how quickly the graph is shooting downward. -1 would be 6.389. I'm going to put -6.4. 0 would be 0. 1 would be 0.9 or 0.86. And 2 would be 0.98. Okay? So as you can see, it's getting closer and closer to 1, but it's never going to cross the horizontal asymptote at 1. So here we go. Over 2 and up 0.98. Over 1, 0.86. 0, 0. -1. -6.4. So this graph here is going to shoot down really, really quick. Like this. Which is fine. And it's going to get closer and closer to the asymptote, but it's never going to touch it, okay? So there we go. So even though you have a base of e, you still graph the exponential function the same way. The steps are still the same, okay? Now, quickly in closing, I want to make sure that you know how to use your calculator when it comes to exponents and base e's, okay? So, I want you to evaluate these problems using your calculators. Alright, so here we go. Okay, now, let's quickly make sure we know how to type this into our calculator, okay? So take some really good notes. Okay, first of all, you type in 5,000, okay? So go ahead and type in 5,000. Okay, then a parentheses. Then a 2. And I'm doing this with you guys. Hold on one second here. 5,000 parentheses. Then hit arrow. So an arrow pops up here. And then type in negative 1.5. And then close your parentheses, okay? Do that. And then hit enter. And you should get this right here. So students, make sure you know how to type in expressions like this into your calculator and be able to get out numbers, okay? Very important. Now how about a fifth root? Okay, a fifth root. Well, students, do this, okay? First of all, push the number 5 on your calculator. So go ahead and push 5, and a 5 will pop up right here, okay? And the reason you're going to push 5 is because it's the fifth root, okay? Then hit math. This button right here, math. Right here. And look at option number 5. It should have a little X like this with radical. Okay, so go ahead and scroll down. Scroll down to 5 and hit enter. Or just push number 5, whatever you want to do. Okay? And when you do that, this should pop up, okay? There should be an X here and a root. Now, some of you have a newer TI, so the 5 might actually go right up here. Either way, this is how you would type it in, okay? And then type in 4,395. Okay? And hit enter. And if you typed it in correctly, you should get this for an answer. 5.352932, etc. Okay? That would be the answer. Okay. One more example here and we're done. Okay, go ahead and type into your calculator 2.5. Okay. Then next is base E. So you'd want to hit second. And then this button here. And when you do, this will pop up. Just like that. Then go ahead and type in .001 and then close the parentheses, okay? And then hit enter. Now let me quickly type that into my calculator. 2.5 e to the 0.001 power, enter, and I'm getting this right here. 2.5 025, 0125, okay? So, hopefully you're getting those correct, okay? Now, very quickly, let's review. I first of all want you to understand what an exponential function is, okay? Make sure you understand this right here, okay? Number two, make sure you know how to graph an exponential function. And these 4 steps right here will really help you, okay? And then, make sure you understand that we're going to use the natural base e, okay? And exponential functions with natural base e are still graphed the exact same way, okay? Nothing changes. And then lastly, make sure you're able to type in expressions into your calculator like these here, okay? Alright guys, call or email if you have any questions.